I have here a formula called the change of base formula, which is a really useful formula, particularly if you're trying to evaluate logarithms on a calculator. It does not look useful. It looks like an alphabet soup. So let's read through this formula and then try to figure out what it means. This says that the log base b of m is equal to the log base p of m divided by the log base p of b. I'm going to pick an easy logarithm for us to evaluate without a calculator and see if we can figure out what this formula is telling us. So let's say we have the log base 8 of 64. All right, so I have got 8 in the place of b and 64 in the place of m. So over on the right, we can see where the m and the b are. Those are now the arguments of these logarithms. And this new letter has popped up, this letter p. That letter p can be any base that you want. So I could pick p equals 2, p equals 10, p equals pi. Any value will work for p. This formula always works. I'm going to pick p equals 2 just to illustrate that this formula works. All right, so let's just plug in. I'm picking p equals 2. So this is going to say log base 2 of m, and in my example, m is equal to 64, over log base 2 of b, which in my example is 8. So I'm just going to make sure that this works. I'm going to do a little bit of triangle of power to evaluate all these logarithms. So over on the left here, I've got that the log base 8 of 64, I need to evaluate that. What's the exponent you put on an 8 to get a 64? That's a 2. So this is equal to 2. The log on the top of the fraction on the right, let's see, I've got the log base 2 of 64. So we're trying to figure out what goes up in the exponent. Okay, so let's see. 2 to the third is 8. To the fourth would be 16. 32. 64, that would be the sixth power. Okay, so I've got a 6 up top. So that one is 6. Let's do the log base 2 of 8. We've already thought through this one. Log base 2 of 8, that exponent is a 3. All right, so all those logs that I just evaluated are telling me that over on the left, I had a 2 equals log base 2 of 64, we just said was 6. Log base 2 of 8 is 3. That was a really complicated way to figure out the log base 8 of 64, but the formula actually worked. This is useful in a calculator setting because I can choose that p to be the log base 10 or the log base e. So this is telling us that the log base b of m is equal to the log base 10 of m over the log base 10 of b, or I could choose the log base e, the natural log. It's telling us that the log base b of m is equal to the natural log of m over the natural log of b. And you can actually pick either one of these and they will evaluate these logarithms for you. So this is actually really helpful when you're trying to find the log base 4 or the log base 7 of something. Most calculators will not do that for you very easily. Either you have to go find the special log base button in a weird menu buried somewhere, or your calculator just flat out won't do it because it's assuming you know this formula. All right, let's see if this works on our calculators. I've got the log base 6 of 36, and I picked this one because we actually know what this one is equal to. Right, the log base 6, if I set up my triangle over here, of 36, we know we need to square 6 to equal 36. So this should tell me that the answer is equal to 2. So I'm going to keep that in mind. So I'm going to use this change of base formula down in the bottom right. This formula says that the log base 6 of 36 is equal to the log base 10 of 36, divided by the log base 10 of 6. So I'm going to go to my calculator and type those two things in. Okay, so I'm going to do the log of 36, which is 1.55630250008, bunch of decimals, but then I'm going to divide that by the log base 10 of 6, and it comes out to a perfect even 2. And like I said, it doesn't matter which logarithm you use. I could easily do this as well with the natural log 36 divided by the natural log of 6. So when I find the natural log of 36, that's 3.5835189385. But when I divide that by the natural log of 6, my calculator tells me 2. Right? So this is a good way to evaluate logarithms using your calculator. You can pick your favorite log. You just can't mix and match the logs on top and bottom. So here's where this formula is really useful. This is going to allow us to evaluate logarithms that we can't do just by thinking about the triangle of power. So this is log base 7 of 241. It's asking us what exponent can you put on a 7 and get the answer of 241. right? So I'm going to evaluate this using my change of base formula. It says to take the log of the m, that's the inside number. So I'm going to do the log of 241 over the log of the base of the logarithm, which is 7. And again, if you prefer the natural log button because you like the way it looks better, you can do this with natural logs on top and bottom as well. So I'm going to type in log of 241, and I'm going to divide that by log of 7. And I get a decimal this time. This is not a whole number exponent. I get 2.8186. So I'm going to round that up to 2.819. Right. And just as a double check, remember, this is supposed to be the exponent that's going to give you 241 if you put this exponent on a 7. So you can check that 7 to the 2.819 is about equal to 241. You're not going to get exactly 241 because I rounded that off at the third decimal place. So if I do 7 to the 2.819, I get 241.1 and stuff. So it's about 241. If I'd kept all those decimal places rather than rounding off, we would have gotten an answer much closer to or exactly equal to 241.